Have you ever wondered what would happen if we kept cutting something up and never stopped? Like this slice of bread, for example. If we kept cutting it and cutting it, what would we be left with? How much could we keep cutting? Thousands of years ago, the great thinkers of those times wondered the same thing. Democritus, an ancient Greek philosopher, suggested that all matter is made up of tiny particles that cannot be subdivided. He called them atoms, which is a Greek word for indivisible. So atom gets its name from this Greek word. It was later found that certain subatomic particles exist inside an atom. These are called the fundamental particles of an atom and are named electrons, protons, and neutrons. In this video, we will discuss the discovery of electrons and their properties. Sir Joseph John Thomson, a British physicist, is credited with the discovery of a vacuum pump. Inside the tube were two metallic electrodes, cathode and anode, connected to a high voltage source. The tube was filled with a gas. Through the vacuum pump, he reduced the pressure inside the tube to 0.01 torr, which is only about 0.1 Pascal. Then he applied a high voltage of about 5 to 10 kilovolts across the electrodes. He saw some rays being emitted. These rays were creating a fluorescent glow on the wall opposite the cathode. He noticed that the rays were being emitted by the cathode, and so he named them cathode rays. Later on, these rays were identified as electrons. In the presence of an electric field, these rays deflected towards the positive plate. This showed that they were negatively charged. If an opaque object was placed in their path, the object cast a shadow opposite to the cathode. This showed that they traveled in straight lines perpendicular to the surface of the cathode. Though invisible, they caused some materials placed in their path to glow. Aluminium oxide placed in their path glowed red, and tin stone yellow. Depending on the composition of glass, they also produced greenish or bluish fluorescence when they hit the walls of the glass tube. They caused a very light paddle wheel placed in their path to rotate, meaning that they could produce mechanical pressure. This showed that they're not really rays, but material particles with some mass and velocity, or in other words, kinetic energy. They also raised the temperature of an object on which they fell due to the transfer of this kinetic energy. The charge-to-mass ratio of these particles, 1.78 times 10 raised to a power of minus 11 coulomb per kilogram, came out to be the same, irrespective of the gas used in the discharge tube. This proved that atoms of all materials contain electrons. To summarize, electrons were discovered by J.J. Thomson using a gas discharge tube apparatus. When the pressure inside the tube was reduced and a high voltage was applied across the electrodes, shiny beams were emitted from cathode, which traveled towards the anode. These beams were negatively charged, traveled in a straight line, were invisible but caused some materials to glow upon hitting them. They could also produce mechanical pressure, and hence it was established that they were material particles with some mass and velocity. They were found to be independent of the nature of the gas used.